Good afternoon, everyone. This is the third OpenStack Bootstrapping Hour session. I'm Jay Pipes. I will mostly be just on mute listening and asking questions today. We have Russell Bryant and Dan Smith going to be talking about the Nova RPC layer and our RPC API versioning. So without further ado, I'm just going to ask Russell to kind of introduce himself, and then I'm going to mute, and off we go.
Okay, cool. So we're going to talk about RPC and OpenStack, in particular the versioning aspect, as just one place to start with how RPC is used in OpenStack. And let's just get started. So we've got some slides. If you look at the wiki page, there's a link to the slides on the Google Doc that you can pull up yourself if you'd like. Okay, so an overview. So we're going to talk a little bit about OpenStack RPC from a high level, and then we're going to look at some code in Nova. Nova's where all this started. All this code originated in Nova. It was later moved to Oslo, and it's also the code that I'm most familiar with. So we'll look at some code examples in there. To get a better idea of what changes look like when you have to change this stuff. So let's start with the high-level overview of OpenStack RPC. So I mentioned before that it originated in Nova and later moved to Oslo. It's now in its own library, Oslo Messaging. And so what this is used for, so all of the OpenStack projects present a public API, a public REST API. Internal to the project, it's internal to Nova. It's made up of several services, and they communicate with each other internally to Nova via via Oslo messaging. And it's primarily backed by AMQP. Now there is, or was, I'm not sure if it's been removed, or I think it may be on its way to being removed at this point. There was a driver for ZeroMQ, but it's not actively maintained anymore. So it's backed by AMQP. Most people use RabbitMQ. Some people also use Cupid, and there's also a new driver for a new AMQP 1.0 driver that was just very recently merged. So So like I said, it's internal communication between services in OpenStack. Just a quick review of the messaging patterns that are used. There's one service sending a message to another service with not expecting any reply. You'll see this referred to in the code as a cast. There's the same thing invoking a method on a remote service and expecting a reply back. You'll see that in the code referred to as a call. So calling a method and getting its return value. And then there's also a one-to-many messaging pattern where one service sends a message to every service of a particular type. An example of that. Well, actually, I think we've removed all uses of that in Nova at this point, but it's still there. There used to be like messages between the compute nodes and the scheduler instances of the scheduler service where they were sort of broadcasting back and forth. But for scaling reasons, we killed all of that. But it's there still. So there's versioning in these APIs, and why versioning is a pretty common thing in software for lots of really good reasons. But before we started adding it to these interfaces in Nova, one of the first reasons was we wanted more explicit failures when there's version skew. When you go to upgrade your deployment, you might accidentally not upgrade everything just right, and then if we want the failures to be much more obvious, like, oh, they're not speaking the same version of things, and make the failure more obvious. Without the versioning, then the failures could be really obscure. So that helps. And then it's one of the many things that we've done in support of doing rolling upgrades in Nova. So that's why it's there. Now, if we look at the makeup of versions, it's a pretty normal-looking version number. There's a major component and a minor component, so x.y. The major number is only incremented if we make non-backwards compatible changes. And we bump the minor number much more frequently. And when we do that, it indicates that a change is made, and we keep track of what change we made for every increment of the version. but every one of those changes is backwards compatible. And then occasionally we come around and do a major increase so that we can drop lots of backwards compatibility code. So the way this works out is when you have one service talking to another, the client specifies that, so it's invoking a method, and it knows that for the other side to properly support the request, to understand the message it's sending, then it's got to implement at least version x.y. And then the server, on the server side, when it gets the message, it looks at that version and looks at what version it has implemented locally and does a check. The major version number must match, and then the minor version, it must implement at least the version that the client specified. And if that check doesn't work out, then it raises an exception back to the caller saying that the version was not compatible.
And if it was a cast, it just gets dropped on the floor, right? I mean, logged, but yeah. The client won't know that it didn't get its thing honored because it was a cast anyway.
Yeah, it's a good point. Yeah. Okay. So speaking of, if you go to jump to the next slide here, if you think about what happens when when you have an environment where the support for versions is mixed, and so that's why there's this version cap in the configuration file in Nova that you set on a per service basis. And so the example of where this is needed, our rolling upgrade support today is for a rolling upgrade of all of your compute nodes. So you want to say, while this process is going, while this process is happening, you say you pin the version to what everything is going to understand in this upgrade process. So, for example, if you're upgrading from Icehouse to Juno, you set this config to say, don't send any messages beyond what Icehouse understands, and then you can undo that configuration setting once the upgrade is complete. Yeah, so it would be nice if in the future, maybe if it didn't require like a configuration change, because you have to, once you're done, you have to change the config and restore all the services. That's kind of something that'd be nice to improve in the future, but it's
Russell, a quick question
out there today. Sure.
Quick question on this. So, do we bump the major RPC API versions for every release?
Not every release. It's kind of on an as-needed basis.
Okay.
If there's not a whole lot of changes, then it's. I mean, it's kind of a pain to I think we'll come to that later in this, talk about what that looks like. But it's kind of a multi-step process to bump the major version. Let's see, not for this. The last release, I went through and did a major bump on, I think, of everything, and then when we looked at it for the Juno release, there hadn't really been that many changes to make it look worthwhile. It looked like more than anything, the compute service had some additions, but not a ton. And the conductor had a lot of things, but all it was lots of removals and. So yeah, it didn't seem worth it to do it in this release just because of there wasn't a high enough volume of changes. The work on Nova Objects is actually making some of this slow down. It's really nice. Which, speaking of Nova Objects, that's actually a really important thing to note with this. If Dan, you want to speak to what versioning of the interfaces does not cover.
Yeah, so really for us, the RPC version covers the kind of the signature of the RPC method that's getting called, and in many cases, like if we're totally replacing the value of one parameter with a different type of thing, like we were sending an int and now we're sending a dict or something, we would bump the version for that. That's not really a good example, but regardless, we have lots of cases where the format of a parameter would change, probably way far away from the RPC interface anyway, and the RPC version wouldn't get bumped to reflect that. So that's an important thing to note here, and it's one of the major things that the Nova Object stuff aims to improve, which is bundling some of the RPC APIs with the code and with the data versioned into a package so that we can make sure that they move together. So that's something that we'll cover in another session later, or I will, and people will throw things at me. But it's very RPC related, but it's a little bit of an offshoot from the specific versioning that we're talking about here.
All right, I keep getting muted. Okay, so from that, let's jump into some code. RPC in Nova. So the way the code is structured, where you find this code for every service follows a similar pattern. You've got the client side in Nova something RPC API.py, and the server side is Nova something manager.py. And an example of how the code would be used, so if you have the Nova API service that's serving up the REST API, if the API needs to talk to the compute service, it's using the code and Nova compute RPC API. So it's using that, which ends up sending a message via Oslo messaging to the Nova compute service, and then on the Nova compute service side, the code that's running is in Nova compute manager. So that's the client and server side of these interfaces. So let's look at an example of a client. I picked one of the simplest ones because it shows what needs to be shown, but it's much smaller code than the compute code, for example. So console auth. And then that link there in the slide will take you to the code. So jump over to here. I don't know how visible that will be in the video, but so if you look at this code, this file contains a single class console auth API. And the first thing you see in here is a big comment block, and the comment, we do this for all the client-side classes, that we keep track of a history of all the changes we've made. And you can see that we had an initial version, we added a couple of things that were backwards compatible changes. Eventually, we did do one major bump to be able to drop a couple of things that weren't needed anymore, and then it actually hasn't changed in a while. We also have this version aliases dict here that's just keeping track of, for every major release we've done, what was the highest version number that it understood. So you can see that in the Juno release, it understands version 2.0, which was the same as Icehouse. But if you look back at Havana, that was before 2.0. It understood version 1.2. So we did some. There was a change from Havana to Icehouse, and so I'll show you what that looks like here. So there's three methods here. There's authorize console, check token, and delete tokens, for instance. And you can see that. So you call it what the argument is that you want to send. It's going to start out assuming that it wants to send the latest version 2.0. It calls a method can send version. It checks to see am I allowed to send version 2.0, and if you're not, then it drops back to 1.2. It turns out that we've made 1.2 and 2.0 equal to each other, so it's actually quite simple. We just change which version number we're going to include in the message, and then proceeds to do the call. So this was needed. Actually, we can actually drop this code because this code was needed for upgrading from Havana to Icehouse, and we only support doing like one release of an upgrade. So this is just kind of old code that we can actually drop. I thought about putting a patch up, but then I was like, well, we're gonna have it's actually kind of nice, so we can look at it now, and then we can rip this code out after.
So just to clarify, whether I can send a decision on whatever line that is basically checking the pin. So looking to see whether the pinning requirement allows us to send the newer version 2.0, and if not, we're going to send the old one. And so if this was a functional change between the versions, in that indented block would be code that does whatever it needs to do to make the call look like it's coming from a 1.2 client instead of the new client. So if we added a parameter in 2.0 that wasn't in 1.2, that block would delete that from a list of parameters. Or if we slightly change something, it would convert it back to the old way. So this is not a very functional change, but that's where you would see that code, and that code is specifically checking the version pin that you might have set when you're doing an upgrade of a deployment.
Yeah, good point. So the version pin, if you look higher up in the file, there's only one configuration option defined here. This is starting on line 26. The option's called console auth, but it's in an option group called upgrade levels. So in the nova.conf file, in square brackets, you'd have upgrade levels, and if you wanted to do a pin for the console auth service, you'd have console auth in there, and you would set it equal to, say, Havana, for example. And we also, so what Dan was just talking about, how usually when you see these checks, there's more code in there that changes the format of the messages being sent. We've got an example of that coming up in a bit of what one of those looks like.
Hey Russell,
yeah.
Could you? I put this on the Etherpad, but just briefly explaining to the audience what the client prepare method does, the RPC client prepare method does.
Sure. So let's go back up to the constructor for this class. It creates self.client. So what the client, it's maintaining context about what request you're going to make, and so when you create it up front, there's some general things, some general attributes that are going to be used for every RPC call that's made. One of those is the target, and the target is the target is actually an Oslo messaging class, but you're defining the topic, which is sort of an NP thing. The topic is effectively saying that you're talking to the console service, and also the default version number that you're going to specify. So if not specified otherwise, it would say that it would say 2.0 is the version that's expected on the other side. It also includes the version cap here in the client object, and the version cap is what comes from the configuration if it's set. So that's the client. So here in each method you have self client prepare, and that's so you have this. You're setting additional context. So for this particular method call, there's some something that you need to override the version. So you're saying for this particular method call, the version number is going to be 2.0 or 1.2, whatever, and then finally using that client context, you do a call method. So it's all kind of metadata associated with the request that's used by Oslo messaging. Does that make sense? Cool. All right. Okay, back to the slides, and we'll look at some more code. So that was the client side. The server side is, again, it's in the manager.py file, so you'll find this in Nova console auth manager.py. So if you click on that link, you come to this code. And again, this is actually not a very big file, but it's the code that runs inside of the console auth service. So you see in the top of this class, we define this testing target attribute with a version number. So this is what has to change every time that if you're making a change to these interfaces, you need to change it on here for the server side. This is just saying this is the version of the interface currently implemented here. And then each of the methods in this class are things that can be invoked remotely. There's not much in terms of RPC. There's really not much else interesting in this file other than just to know that each of these methods, the way that they're called is that they're called remotely via RPC. So that's that. So jump this slide real quick. And let's look at what like a version bump would look like. So what I did is, so you do a bump with the minor version. That's something that has to be backwards compatible. And to show an example, I looked at the Nova Compute service and found the change for the latest minor version bump that was done, and that's 3.35. So we've bumped the major version a couple of times, and then there's actually been 35 changes since the last time. So probably for the next major release, it might be worth doing a bump for Nova Compute, a major version bump, so that we can drop some backwards compatibility. So let's jump over to this this page and look through the changes. And best place to start is here. If you look at Nova Compute Manager, so again, this is the server side of the RPC interface. You'll see that first that version number got changed. So it was updated to say that the version currently implemented by the Nova Compute service is now 3.35. And the actual change that's made is to a method called reserve block device name. And what was actually being done here is change the type of return value. And to do that backwards compatible way, they added a new argument that has a default value. So you can add arguments, and that's backwards compatible. As long as it has a default value to it, so that if it's an older client and that doesn't send this additional argument, then there's no problem. Just like local Python calls. So it added this argument, and now if the client's new enough and says that it wants the new type of return value, then it'll return that. Okay, so look at the client side, Nova Compute RPC API. There was an addition to show in the version history to say that this method, reserve block device name, was updated to return a block device mapping object. And now, so now we get down to the client changes. This kind of related to what Dan was talking about earlier. Usually when you have these version checks, there's some more code involved, and that's what's happening here. So the code here, the way it starts out is it starts out assuming that it's going to send the newest version. It has this dict of all the arguments that are going to be sent to the remote method, including the one that says please return the new return value type. And then it does a check to make sure am I allowed to send version 3.35, and if so, it stores that off in this version variable. But otherwise, if not allowed to send that version, then that means that the remote side does not understand the return BDM object argument, and it pulls that back out of the argument dict, and then updates the version to say, well, we're not expecting .35 anymore. Now that we're not asking for the new return value type, 3.16 is good enough. And then it proceeds to do so it does the call the remote method, and trying to make sure that it has the object type. It ends up it gets the object locally if the remote side wasn't able to return. So this is an example of how to make what backwards compatible change looks like when you have to bump the minor version. And so if you go look through Nova Compute RPC API, you'll see quite a bit more of this kind of code where it's trying to it checks to see what version it's allowed to send, and if not, it has to do various tweaking to the arguments and expectations on what's coming back to match.
Hey, Russell.
Yep.
Quick question for you. We're getting, by the way, a little bit of echoing on your side. I think that it goes in and out. But anyway, my question, and I have this on the Etherpad as well. Can this system that you're showing here, can it handle the removal of parameters from an RPC API method? So let's say disk bus equal none or whatever, or I guess let's take one of the positional arguments and not one of the keyword arguments. So if we removed, I don't know why, but let's say we removed instance from reserved block device name RPC API method, is that something that the versioning system supports?
Sorry about the echo. But to answer the question, yeah, it definitely does support removing an argument. And the way it would work is all you have to do. So on the client side, you would just not send that argument. Well, let's just I guess talk through what that would look like. So first, you would have another condition here in this. Am I allowed to send 3.36? And if so, then you would delete instance out of that list of arguments, and then you're set. But on the manager side, all that would have to be done is you would change instance to be a keyword argument. So you just need to make the remote implementation not blow up if the argument isn't specified. So you need to make it have a default value, and then in the actual implementation of the method, have it deal with the fact that argument may be none.
So important piece of this to note is that all of the manager side dispatching of the calls is done always by all arguments, right? So even the positional arguments are dispatched by name, so you can convert a positional to a keyword argument easily and have it gracefully handled.
Yep, and then once you go and do the major version bump at some point in the future, then you can go through and remove like the fact that you have this keyword argument not actually used, and then like any weird code that you might have inside the method to deal with the fact that an argument may or may not be specified. So that's kind of the cleanup that you get to do as you go through and do a major bump in the future. All right. What else do we have here? Next thing was so if you do a major version bump. So if you need to do a major version bump, there is a wiki page that goes into this in some more detail and points to some older examples of when this was done. But it's sort of a several-step process. So just for example, if you're starting with version 1.0, the first thing you do is you add support for 2.0 to both the client side and the server side. But you need to on the server side, it has to support both interfaces. It has to have 2.0 and 1.0, so it might be something like you leave the existing manager class as the 1.0, and then you have a new one for 2.0 that proxies to one, and then you have the service exposing both versions at the same time, what is allowed. And on the client side, you need to have the client side support both, and the way that works is kind of like what we've been looking at before, where it does a check against the version cap or the version pin, and am I allowed to send 2.0, and if so, great, and if not, then it falls back to 1.0. Eventually, you can go back and drop the 1.0 code once it's not needed for like upgrade purposes. But that's sort of the high-level view of what it looks like. It's not hugely different from the code, but you just have to do it in a few steps. And a couple of links. The Oslo messaging API has like a lot of has good documentation. This stuff published from the code itself. That's the first link. And then also in the Oslo messaging library was being designed. When the library was designed, it was a new API added to it. The original code had a slightly different API. So that way we can keep all the design notes from that screen, and it looks like it's still fairly accurate and has some good examples and stuff. And that is actually all I had. But I can certainly take any questions, or we can chat about other stuff you guys have.
So I've got one more question for you, Russell.
Sure.
And I guess this could be both on the Oslo messaging side as well as within Nova RPC. what should Nova contributors or OpenStack contributors in general look for as far as any changes in the Oslo messaging library or any changes to the RPC system within Nova that you can see over the next, I don't know, 2 release cycles or something? Are there any blueprints that are sort of in process with Oslo messaging that would make significant changes to the way that we use that library?
That's a cool question. I really only have one thing that comes to mind, and I haven't been following Oslo messaging as closely as I would like. Like everybody else, there's tons of stuff going on in OpenStack, but I'm not aware of any like major changes like API-wise the way we use it. There's some interesting work going on. I find interesting in terms of what drivers are available. I mentioned this briefly before that there's a new driver that just got merged for AMQ1. And what's interesting about that, so the way the existing drivers work, like using random, you have to have a centralized broker. So that's kind of scaling pain points with an OpenStack deployment. Is you have this central broker. That really the biggest benefit of the attempt to add ZeroMQ is having this a little bit more decentralized approach. And what AMQP 1.0 allows is both brokered messaging and also peer-to-peer messaging. So it gives us a system where we can easily do both in choice, essentially on the messaging pattern we're using. And there's also a project called Dispatch. That's part of the Qubit project, I think, that it gives you like a sort of network of message routers. So imagine kind of like instead of having a central message broker, you have like a distributed network of them where you have sort of subset of your deployment pointed to one router. And I think that's interesting from a scalability point of view. The code's very new, and I'm not sure how many people have really tried to set it up for real and see how that works out. But just from like an architecture point of view, I think that's something worth trying out. That's kind of the biggest thing on my radar is I'd like to give that more of a shot and see if that relieves one of the competition points we have. But that's it. I think that the API seems pretty stable otherwise.
Thanks, I appreciate that. I don't see any other questions on the Etherpad right now. Matthew had asked a question earlier about the slides. Yeah, we'll put a link up to the slides on the wiki page there. If anyone has any questions, feel free to drop them into the Etherpad now. Otherwise, I'll be forced to ask questions of Russell, as I've been doing the whole time now. And Dan doesn't talking much in the OBH sessions anymore. So let's try and keep Jay questions to a minimum. So I thought of something. Maybe you could explain a little bit about how Oslo messaging creates the exchanges in. I know that I think it was the third or fourth slide, you had something on there about one-to-one, one-to-many, and a fan-out. Perhaps you might talk just slightly about the terminology around exchanges, and I know that there's a direct, a topic, and there's one more. Address that, because you see the terminology exchange used quite a bit in the Oslo messaging documentation.
Okay, so the exchanges and topics and stuff, that all came from AMQP. Oslo messaging sort of attempt to abstract it a little bit, because in theory you could use something else that's not MQP behind it, but you still see it is in the API quite a bit. So what you need to know. Okay, so there's. Okay. The way all the things that we've talked about. Okay, the direct, the one. Okay, yeah, I remember how this works. So the topic exchange, that's what's used most of the time. And so for Nova, it creates, there's a topic exchange called Nova, and then for each service, there's a topic for the service name. So for example, compute, and then it has another topic, compute.hostname. And so if you want to send a message to a particular host, then you would send it to the topic compute.thehostname that you're talking to the message to. Another way to use it, so it sets up like both of those topics for every service. It's sort of a common code in Nova. So this, on the scheduler, we don't send messages to a particular instance of the scheduler. We don't care which scheduler handles a scheduler request. So all messages are sent to the scheduler topic. And when you send a message to the scheduler topic, any instance of the scheduler service is going to pick it up. At least according to the at least older AMQP specs, those messages are delivered to services in a round-robin fashion. So in any case, so you send a message to the scheduler, and then it'll go to one of them. It doesn't really matter which one. And then for fan-out cast, which I said I don't think nobody actually uses anymore, it's on the AMQP side. It's not a topic exchange. I think it's a fan-out exchange. I can't remember what that was called, so I don't remember. Then there's a direct exchange, which we use for sender replies. I think. Yeah, I'm actually a little lazy on that. I haven't looked at that in a long time. But the important thing, really important with Oslo messaging, it's really the topic. Like that's what's specified in the API all over the place, and that's how you specify which service you're talking to. That's pretty kind of hand-wavy answer, but yeah, I might be able to pull up. Yeah, if I try to dive into the code, I'm going to be looking around trying to find the right place to show you where that's set up. I'm pretty sure it's in Nova service.py is the common place where it sets up the sort of the common stuff to say I want to subscribe to topic for the topic of my service name, and then also my service name dot my host name.
It is. It's okay. Nova service constructor, if I remember correctly. It accepts a host and a topic argument.
Awesome. Well, there you go. So. I guess it's also interesting to note that Oslo messaging, it's used for RPC, which is services. The other major use case for Oslo messaging is used for notifications. Notifications, they still use the work, the major things, but they're not versioned at all in any whatsoever. That keeps coming up, like every now and then, and everyone's we should totally do that. And then, I don't think it's been done. So if anyone's going to be a project to work on, then that'd be nice. But the Oslo messaging docs for notification stuff pretty well.
So on that, I think I'm just going to mute you. Okay. So on the notification side of things, what you were just talking about, you went into kind of shotgun mode there for a second. But I think what you were saying was that the notification payload is not versioned, and therefore we have no fluid system like we do on the RPC API for managing differently different nodes that are sending notifications with different formats at this point. I know that Sandy Walsh and Julian Denjou and some other folks have have been talking about making a contract around notifications. Unless I'm mistaken, that's pretty much what we're talking about with versioned notifications, where you have a payload that has a version tag in it, that the schema for that version can be read by the notification clients and understand how to interpret the notification payload. Would that be an okay way of describing what's been proposed so far?
Yeah, that sounds all right to me.
All right, well, it looks like we don't really have any questions from anyone. I was really hoping Matt would ask another question, but I guess not, or one of the Matts. So I guess we'll go ahead and wrap things up a little early this week. I want to thank Russell for coming on the OpenStack Bootstrapping Hour, and thanks so much to Dan. And we will see you guys, I think, in about a month or so. The next Bootstrapping Hour, let me just double check this. It is. We are skipping the week after next because it's the day before people start arriving at the summit, and we'll pick it up the week after the summit, I believe. So I believe that's November, I want to say 15th or 16th. But anyway, you can check the wiki page, and we'll have an Etherpad link up there for the next session. And thanks, everyone. I'm going to go ahead and stop the broadcast. Thanks.